Alright, so in this very short tutorial, I'm going to go through applications in 3D. Now, what you need to do is you need to visualise, we've been doing right angle triangles, but at times you need to use them in situations where we have 3D shapes. So you can see over here, I could, for example, have over here, I could have a square base pyramid, and in which the height here, ooh, what are we doing? The height here can be found using what theorem? Pythag, yes. Now, another thing is, you could also be given an angle and you can use basic trigonometry that you know just to apply it in 3D settings. So, what I might as well do is I'll pause this video now. I'm going to zoom in and we've got a question that I'd like you to try, and I'd like you to try it first because it's actually fairly straightforward and this really sort of captures what you'd be doing in 3D applications. So, if you have a look at this, we've got a diagram, shows a tent, and we've got a rectangular base. Now, a rectangular base, and what happens is that we have got a tent, a pole, in the middle of this rectangle. So if this is in the middle of this rectangle, then it would be fair to say that wouldn't it be in the middle of this distance here? Would you agree that that might be the case? Otherwise it wouldn't be the middle. So we've got to apply a few things in here. I'll give you the hint before you get you started. We've got to use Pythagoras theorem. And we also have to use probably SOHCAHTOA. SOHCAHTOA. Now, I'm going to leave that up. I'm going to pause this video. I'll certainly go through it with you, but I'd like you to have a go at this question, please, now. And the heading is Applications in 3 Dimensions. I'll let you go now. This video, and I'm also going to unpause this thingy-majingy, which is over here. Press play. All right, so what we're going to do, thank you at the back, I shouldn't be speaking over anyone, is we've got a rectangle. This is a rectangular base, and what can you tell me about a rectangular base? The rectangular base, these angles here are what? They are 90 degrees. Okay, good. Now, same thing if it was a square base. They would still be 90 degrees to each other. Otherwise, it's not a rectangle or a square. So, we have the triangle. This triangle here is a right angle triangle, which means that we could use good old Pythagoras' theorem. And a lot of the time, that's what you'll be doing. So we've got 5, this is 12. So of course, what is opposite to the right angle, that has to be the hypotenuse. So if you can't identify that, you're going to get into some problems. So what we could say is that this distance here, we'll just call h for argument's sake, h squared is equal to 5 squared plus 12 squared. Now, 5 squared is 25, 12 squared is 144, so that's 25 plus 144, which is equal to 169, and hopefully you should know that the square root of h squared is going to give me h, and the square root of 169 is going to give me just 13. So we've got h is equal to 13. Now that's all well and good, but we're told that this is the midpoint. Well, the midpoint of the tent means that we're going to be looking at the midpoint of the line TR. So the midpoint of the line TR is half of 13, so we can therefore say that TR is equal to 13 over 2, which we know is equal to 6.5 in decimals. TO, yes, sorry, TO, thank you. So TO is equal to 13 over 2, which is 6.5. Now what we've got is we've got a right angle triangle, and with this TO, this is T, this is O, and this is P, and we want to find the line segment, or the length of the line segment OP, and of course this angle here is 48 degrees. Now we have to be asked, what are we told? Well, we know that this is 6.5, and this is the adjacent to the angle. This here is adjacent to the angle. We also are concerned with this distance here, which is opposite to the angle, so we must use tan theta is equal to opposite over adjacent, And of course, theta though is 48 degrees. Now let me just share something with you for the calculator. There's a few students there that didn't get the right answer, and I'll go into why they didn't get the right answer. The opposite is equal to what we're looking at for, and the adjacent is equal to, or we'll call that OP, the line OP, and the adjacent is 6.5. Now if I rearrange that, I'm going to get that the distance, or OP, is equal to 6.5 times tan of 48 degrees. Now, let me show you just quickly as why if you get something else, because I'm going to tell you that approximately that was 7.22, I believe. Is that right? 7.22, and we're going to say meters, but don't forget your units. Now, if I go to the CAS calculator, you can notice in the settings, you can see here this angle of radian. Now, we're going to get into radians in Year 11 methods. It's going to become a lot more applicable. Degrees mode. Now, you're going to generally have your calculator in radians mode, but for this here, when you're calculating degrees, rather than changing the settings, I want you to get used to having it in radians. However, so we go okay, it's in radians, but the thing is that when I'm finding tan 48, if I do 6.5 times tan of 48, trig tan of 48. Now what's going to happen is, because this is in radians mode, it's going to give you an answer in radians, or it's going to give you the incorrect answer. How many people got 7.8 on if you did it on your CAS? Was there one? There's a couple. There's maybe one or two more. That's the incorrect answer. We know that the answer, if you did it in a scientific calculator, the scientific calculator just works out in degrees. So what would we do? First of all, I'm going to go up here and I'm going to go press enter. And enter is going to copy that down so I don't have to waste my time doing it again. You had a question, Amelia? Yes, that's right. You have to put the degrees. If you put the degrees sign in here, and how do I do that? I press which button? Pi button, and I go to degrees. And then when I do that, you can see that I've got, in this case, this automatic answer. It's an exact answer. If I press Control Enter, that's just my calculator settings. If I press Control Enter, that's approximately 7.22 to 2 decimal places. Okay, so make sure that when you're in radians, which you should be in methods and beyond, you make sure that you put that little degree symbol in using radians. Because I want you to keep it in radians, and you can use degrees. When you use degrees, use a little degree symbol. Okay? But don't forget, put the degree symbol in. All right? It'll help you for next year, because you don't want to be confused. I'm going to stop the video there, and I'll stop the video there so it's